Reason is quite simple. Our team is smaller than it used to be, and the code is still same size. So we need to be more efficient to work. So where we feel doesn't work. Yeah. Okay. So why we did it, or what's the most annoying part that can be easily make automatic is from when you submit package. So we use GitHub, so there's some quite famous button to merge pull request. So you create some page, someone review it, that needs to be done manually. Of course, there's also some helpers, but when you have the patch and integrate it into your code, then your goal is to have it in a factory. And it's good to have it tested to prevent some trivial errors like syntax mistakes or something like missing license check, missing changelog entry. Otherwise, factory guys said just, oh, we don't want it, redo it. So it's annoying, so it would be nice to have some automatic checks and don't bother factory guys because there also doesn't have so big team. So what we used to do for such submission in past, you need to create package from the source codes. So there's some commands, so you need to manually type something like make package, it creates a tarball, it creates a spec file, changes file. Then you need to test the build. If it builds in a build service, this is usually the most time-consuming step because testing build for YaST usually takes around 10 minutes. So you're just waiting if it's built. Then you run some tests on it. Then you submit the package to devel project, which is for YaST is YaST devel or devel YaST. Some of this combination. And then you need to create the submit request to factory. So it's quite a lot of steps. It takes some time. So usually all these steps took half an hour. So if you want to release 5 fixes, just these steps takes 2.5 hours for you. And we want to be more efficient. So we are looking for some solution. The first one is using Jenkins. Jenkins is continuous integration server that works the way that it pulling Git repository. So it doesn't depend on GitHub. It can work with any Git repository, also with CVS or SVN. And then have some predefined steps that it do. And that's all. And it can send you an email if it succeed or failed. So the first step we did is to create a job for each YaST module. YaST have around 150 modules, so it's quite a lot of stuff. And create script for each module with these steps because that steps can be slightly different because some modules use auto-tools and makefile, and some use just CMake, and some use something different. So we have 150 scripts that differs. It's improvement, but the problem of this solution is that it's generate a lot of false positives because YaST modules depends on each other. So there is manually inserted some dependency tree. That means if you create a new core, then it starts a rebuild of whole YaST just to check if something is broken. So someone changed core and every developer that your 20 modules is broken, but you don't do anything. And also sometimes it breaks because it runs these steps on the Jenkins node, which is a dedicated machine for it, but there is dependencies for such modules because there is some C parts, for example, lib storage. So YaST2 storage depends on lib storage, and you cannot build YaST2 storage with the old version of lib storage. So you submit new lib storage, and then you should wait, install on this node new version of lib storage, and then you can build YaST2 storage there. So it's not automatic, and it happens quite often. So result is that people start ignore it and just do it manually like before. So that's not our goal. So we give a next attempt. Yeah, one interesting thing that you may notice, the second link is our public, not our, it's openSUSE public CI server. And we moved here because the original instance was on the internal Jenkins, so it's not visible for the people outside. But this is the public one. You can open it now and just check. There's a lot of jobs, and there is all YaST modules here. So you can check it. So that's one improvement in our openness. So what we want is OSC. Probably you know it, just to remind, it's a command line tool to communicate with build service. The reason why we choose this technology is to have the consistent build, because OSC can build package in root, and OSC ensure that recent packages is installed in this root. So you don't need to worry that some version change, because it automatically take it. It have also one quite nice advantage, that we can build for older distributions, like openSUSE 13.1, because the old Jenkins node built just for factory. Otherwise, there will be mixtures of version on Jenkins node, but if you use root, you can have more roots for different environments, and it can live on one node. So we start using OSC, but still there is some steps that not so easy, like creating package that need to be before running OSC, because you need to create package, copy it to your OSC file, and then do something. So we want to improve the situation even on this part. So the nature step, we did this job after the conversion from YCP to Ruby in YaST. So the nature choose is different build environment. That's Rake, which is nature for Ruby. And just to ensure you, it's not revolution, it's just evolution, because we have everywhere Rake files, which is for Rake, but internally we still use the old make or CMake, depends on module, but it's specified only in spec files. So we split it, and you can use anything in build phase. So for building, you just can call make, CMake, or even a Rake. Some modules use already a Rake before, so you can use it. But for packaging, we always use Rake. And the reason is that for Rake, you can have easier libraries. It's much easier than for make or CMake, and it's quite easy to keep it up to date. And the biggest advantage why we choose Rake is that if you need something more complex, you can program it in Ruby. I am not sure how many of you try do something with auto tools or CMake more complex, but their scripting language which is M4 for AutoTools, and even I don't know name for CMake, but it's usually big pain, and I need to Google a lot to do quite trivial stuff. But when you have Ruby and you work with Ruby every day, it's really easy to write something more complex. So we decide for Rake, and to make it better, I create some generic gem packaging tasks. It's open source, it lives on GitHub. And its goal is to have generic integration of project and build service. There is task that create package, which is integrated with Git. So it uses some Git tarball command. And it can call the OSC, so it creates tarball, it copy the sources to your defined project and try to build it. You can try to, what's more? Yeah, create submit request, commit it to your devel project, and so on. And there is dependency, so you just specify what you want at the end. So what we have on our Jenkins node is one single command, and that command is rake osc sr, which means create submit request if needed to factory. And it knows that to create submit request, they need to create tarball, they need to try test build if it builds, and if yes, then commit it to devel project, create submit request if version increase. That's one of the change, because if version doesn't increase, the factory doesn't accept the package. So only if version increase, submit it also to factory. That also prevents to create too much submit request, because factory guys doesn't like to have thousands of submit requests per day. So only if version increase. So the packaging task is the generic part, and it's already used for more projects. It's used in YaST, some internal projects of SUSE, and I think that also some other projects look into it. I'm not sure on which part is it. I just get some questions, I answer it, and then get no feedback. So maybe I try to speak with some guys on this conference. And what's specific for YaST is YaST Rake. That's on top of packaging tasks and have some specific configuration and specific tasks. So it specifies the devel project is always YaST devel for YaST parts. It always submits to factory. That they have some special metadata grabbing, like all YaST modules contain the RPM name file, which includes the target RPM name, because the Git repository doesn't match the RPM name. So there is some specific things for YaST, and there's also some nice tasks for YaST. And one that I like the most is to run a YaST module from Git. It's correctly set up all paths. Like I'm not sure how deeply you know YaST, but there's some part you can specify where to load YaST modules. So if you want to run it from Git, you need to specify some path. So it do it for you. You can just specify a rake run, and it runs module from Git. So you can just try module even if you don't install it to your system. It's quite useful also for testing. Okay. So that's what I want to say. I have here some contacts for YaST team. We live on public IRC on Freenode. There is a whole team. We destroy the internal IRC channel, so there's our only place where you can reach us. Even if you work for SUSE, you need to go to Freenode to reach us. And we have public mailing list where you can just ask some questions. We usually respond to one day, so we try to communicate. Okay, so do you have some questions? Well, maybe I'm so clear or so confusing that no one have question. So, yeah, one question, nice. So, Oliver?
What happens when you get a failure? Whence do you get the logs?
Yeah, thanks for the question. It's good. We get an email to mailing list. It's just commit mailing list. There's some automatic reports, so it goes there. And also, Jenkins have feature that it can directly mail to the author of Git commits involved in change. So he see Git history, so we see, yes, there is changes from 3 guys, so also mail these 3 guys that have email in his Git account. So you get email, it failed, it create complete log from the run of rake, and it's usually there because we run everything verbose to have easy history. You can easily get a history. And what's the best thing? That it's consistent. So if you run rake OSC build, for example, on your machine, then it do exactly same like our Jenkins node. Of course, there's some, it doesn't catch everything, like failures for S390 or some specific architectures like ARM, because we have just testing node for x86, 64, but it usually cases. Yeah. Any more questions?
Are you aware of the BOSS system made for Migo, Mer, Yolla uses it? As far as I understand, I'm not into that, but I think they still use it. Are you aware of that system? I think the spec or the goals sound very similar. So, and I think it's open source, so you could have a look there and steal some ideas or whatever.
Yeah, I know there is some more systems for it, and we looked into some opportunities, but this is quite nature because we use it already Jenkins in past for other projects, so we know it, and the packaging task actually not start in YaST. We start doing it for WebYaST. So we have it in past just when we start with WebYaST, and we decide it's the right way to go. And actually, it's quite easy code. It's not rocket science. The Ruby is quite a good expression, and it usually just calls some command line clients or command line scripts. So it's quite easy. It's a very small library, but it works really nice. Okay, anything more? Okay, so thanks for your attention, and see you in some next presentations.